All right, welcome to 5.5. We are going to look at multiple types of equations, some involving bases with exponents, and then some involving logs. One of the things you have to pay attention to, and I will talk about it as I teach it, is how do you know when to tackle each type of problem? Okay, so right off the bat, the very first one with the 10 and the 16. This is different than what we've done in the past. If you remember when we were doing, say, like an x 8 to the x plus 2 equal to 16, our goal was to get the same base on both sides. Break them down into 2's, okay, and then set the exponents equal to each other. But in this case, I cannot get the same base from a 10 and a 16. So now I am going to use that concept that I've talked about before, and that is I want to rewrite it into log form. Anytime you're not sure what to do, try that method. So I'm going to change it to log base 10, and I don't have to write the 10, is equal to x over 2. All right, so you're probably already thinking a little bit. If my goal is to solve for x, there's only one thing I really have to do here, and that is multiply both sides by 2. So x is equal to 2 log 16. And we'll just leave it like that. That's an exact answer rather than trying to get a decimal out of it. All right, on the second one. If you remember that we talk about base exponent equals our answer, if I want to convert that into log form, it's log base b of a is equal to e. So therefore, I want this equation to look like that. So what I'm going to do first, I am going to first add the 70 to both sides. That now allows me to write it into log form. Again, the reason is I can't get the same base with a 4 and a 70. So log base 470 equal to a 5x plus 2. Goal is to get the x by itself, so I'm going to subtract the 2 over. So log base 4 of 70 minus 2. And remember, this minus actually means minus. This is not divide. Remember, it's division if it's log 470 minus log 42. They would both have to have logs. In this case, they don't. Equals 5x. Last thing I'm going to do is divide everything by 5. So x is equal to log 470 minus 2, all divided by 5. Okay? Another way to look at why these two don't actually subtract is because, remember, log 470 is a number. So it's like an operation. You have to do that before, okay, you can subtract the 2. So always going back to order of operations. All right, the only difference with the third example is it involves e. So instead of using log, I'm going to do ln. So I'm going to rewrite it in natural log form. So ln base e, I don't have to write the e. Equal to 5,000, forgot the 0, equal to 2x minus 5. All right, just like this previous example, I'm going to add the 5, divide by 2. So x equals ln 5,000 plus 5. That does not mean multiply. Okay, it means add, and then divided by 2. And I'm done. Exact answer. All right, I like this one. I always like puzzles, so for this one, I see 2 natural logs, so therefore I got to be thinking about rewriting it into exponential form twice, okay? So the very first time, here's my base of e. So e to my exponent squared is equal to my answer of ln x. But now I have a second natural log. So now e is my base again. This e squared is now my exponent is equal to x. So all we did was convert it twice. All right. When we get to these two problems, okay, big idea I've already highlighted is make sure that we are noticing that there are exponents on both sides of the equal sign. So anytime something changes, you got to be thinking, well, that means there's a different way in which to solve it. Again, I cannot get the same base out of a 4 and a 3. If it was like a 4 and a 16, yeah, then I would get the same base. So in this case, and what we're going to do is so that we are consistent throughout, is we are going to take the natural log of both sides. Okay, remember with change-based formula, we can do log, we could do natural log, we can do anything we want as long as we're consistent. So I'm basically going to do the natural log of both sides. So what that looks like is now it's the natural log of 4 to the x equal to the natural log of 3 to the 2x plus 1. All right, from here, I am going to remind you of the property that we had where we have log base b of a to the x, and that x gets moved out in front, and so then we have log base b of a. All right, so I'm going to use that concept here. I'm going to move these out in front so that I get x natural log 4 equal to 2x plus 1, which I'm going to put in parentheses, ln 3. Why parentheses? So that I remember to distribute that 2x to the ln 3 and to the 1. All right, so now I've got x ln 4 after distributing 2x ln 3 plus 1 ln 3. All right, we've been doing this since chapter 2. Reminder that when you have multiple x's, step number 1, we talk about get x's on the same side. Number 2, we talk about factoring the x, okay? And the reason why is so that we can then divide by whatever's left over, and then the x is all by itself, okay? All right, so let's go through that. I am going to move this 2x to the other side, and so now I've got x ln 4 minus 2x ln 3 equal to just a single ln 3. I am going to factor out the x. So I did step 1, I got the x on the same side. Now I'm going to factor out the x. Now I've got ln 4 minus 2 ln 3. So the x disappears from both, but everything else stays. Okay, equals ln 3. And now to get the x by itself, I'm going to divide by this parentheses here. And so I will eventually get x is equal to ln 3 all divided by ln 4 minus 2 ln 3. Okay? All right, one thing that I don't want you to do is please do not cancel the ln 3s. Reminder that when you have pluses and minuses above and below a fraction, that these are like a married couple, okay? They get canceled together, okay? So we cannot cancel out those ln 3s. All right, second one here, it's pretty much the same thing. I'll just go through it again just so that you see it. So first thing, step number 1, take the natural log of both sides. So now I've got ln 5 to the x minus 3 equal to ln 2 to the negative 4x. I'm going to move these out in front to get an x minus 3, put it in parentheses, ln 5 equal to negative 4x ln 2. All right, from here I am going to distribute to get x ln 5 minus 3 ln 5 equal to negative 4x ln 2. All right, so now I'm on to my little checklist here. I'm going to get the x's on the same side. So I'm going to add this 4x over. At the same time, I'm going to add this 3 ln 5 over. So now I've got x plus 4x ln 2 equal to a 3 ln 5. Step 2, I am now going to factor out the x, leaving a, whoops, I forgot to write ln 5 here. Okay, leaving an ln 5 plus 4 ln 2 equal to a 3 ln 5. Divide everything by the parentheses, and x is equal to 3 ln 5, all divided by ln 5. Again, do not cancel these ln 5s, plus 4 ln 2. And we are just leaving it like that. We're going to leave it as an exact answer. All right. Third type of problem to look at. So now we've got bases with exponents, but we've got multiple of them, okay? And it's not a situation where we can just have, one on each side, okay? But I also noticed that not only are the bases the same, so are the exponents. They're very, very similar to each other. So we are back to using that idea of U substitution. Okay, so what that means in this case is I see a 3 to the 2x and a 3 to the x. So now remember, a 3 to the 2x is the same thing as 3 to the x quantity squared. Remember, if I distribute that 2, I get 3 to the 2x. So what that means is I see this as u equaling a 3 to the x power, which means my 3 to the 2x is a u squared. So this becomes 0 equal to 2 times u squared minus a u minus a 3. All right, from here I am going to try and factor. If I can't factor, quadratic formula. Okay, we'll try factoring. So let's put a 2u here and a 1u here, because 2 times 1 gives me a 2u squared. Okay, and then I know that I need a 1 here, so I can't put the 3 in the opposite parentheses because then it'll multiply by the 2, so I'm going to put it here. Since the 3 is negative, that means it's got to be negative and then plus 1. If I FOIL this out, I get 2u squared, negative 3u, plus 2u is negative 1u. It worked, and then negative 3 times 1 is negative 3. All right, so from here, now I've got 2u minus 3 equal to 0, or u equal to 3 halves, okay, and then u equal to negative 1. Now I've got to change it back. So 3 to some power is equal to negative 1. Well, we know that there is no exponent in the world that will ever give us a negative number. So therefore, this is an extraneous solution. We can't use that one. Okay, but if I got a 3 to the x is equal to a 3 halves, okay, well now I got to think about how I can do that. Okay, so I can put this in log form and say x is equal to log base 3 of 3 halves. All right. Again, on the second one that I see here, I see a 2 to the 2x, so just like my 3 to the 2x. So this time I am going to use my u substitution, but u is equal to 2 to the x power. So I've got a 3 times a u squared minus 11u. I'm going to subtract the 4 over, minus 4 is equal to 0. All right, right off the bat, I see 3 times 4 is 12, which is very close to 11, so I'm thinking that this is factorable. Okay, so I'm going to try it. So 3u and 1u, that multiplies to be 3u squared. Now, I need to get a 12, which means the 3 has to multiply by the 4, and it has to be a negative, so I'm going to put a negative 4 over here. All right, and then that gives me a plus 1. If I FOIL this out, I got 3u squared. I get negative 12u plus 1u is negative 11u. It worked. And then 1 times negative 4. All right. So now I got 3u plus 1 is equal to 0. U equals a negative 1/3. That means a 2 to some power is equal to negative 1/3, which we already learned. Impossible. Okay, not possible there. All right, so now I've got a u minus 4 is equal to 0. So therefore, I got a 2 to some power is equal to a, sorry, if I go too fast, u equal to 4. So 2 to some power is equal to 4. And now I can say that x is equal to 2. Hopefully you know that 2 squared is 4. All right, now we're on to ones involving logs. So everything up until now, we have been dealing with the idea of a base and an exponent. All right, so what I did was I kind of split it in half. The 2 on the left are the same, and then the 2 on the right are the same. Big idea. Okay? always condense first, whether it's a problem on the left or whether it is a problem on the right, okay? So earlier we were doing some pluses and minuses, but I said they didn't equal multiplying and dividing, and the reason is you didn't have log on both of them, okay? But now that I got a log on both of these, I can now condense it down to log base 3 of an x plus 2 times an x equal to a 1. All right, once you get it into log form, you got to be thinking about converting it into, exponential. So therefore, I got a 3 to the 1 is equal to, and I'm just going to go ahead and distribute this here, x squared plus 2x. All right, we just did a bunch of factoring questions, so I should be thinking the same concept. So 0 equals x squared plus 2x and then minus 3. And then from here, 0 equals x plus 3 times x minus 1. After that, I get x equal to negative 3, x equal to 1. All right, so now, not so fast when you go to on to the next one. So up at the top here, one of the things it talks about is, besides just the expanding and condensing, is we got to pay attention to domain, okay? Because we have to check for extraneous solutions. We already saw an extraneous solution earlier. All right, remember, we talked about if log base b of a equals e, the a has to be greater than 0 because you can't raise something to a power and get a negative number. So therefore, I have to be thinking, well, right now, x has to be greater than 0. Over here, if I had x plus 2 is greater than 0, that means x has to be greater than negative 2. So since I have a negative 3, it doesn't work. Okay, there's an extraneous solution. If I were to plug the negative 3 in here, I would get log base 3 of negative 1. That's a no-go. All right? And obviously it wouldn't work here either because of x is greater than 0 means that it wouldn't work in that one as well. So therefore, I got x equal to 1. So I started off with that one right off the bat because I want you to think about that and always check for it. All right, so now what I'm going to do is I am going to go to this problem, and I want you to compare the two, and I'll talk about it as I go. All right, so we're going to do the idea of condensing first. So log base 7 of x plus 2 times x minus 2 is equal to log base 7 of 12. All right, if you have log on both sides, which I do in this case, then that means we can kind of cancel out the logs or ignore the logs and just leave the rest. So x plus 2 times x minus 2 equal to 12. If you think earlier when we were doing problems like, say, a 5 to the x minus 3 equal to a 5 to the 2x, we ignored the bases and we set the exponents equal to each other. Very similar concept, okay? So from here, I am going to solve, and again, pay attention to, start thinking ahead. Let's see, x has to be greater than a negative 2. Okay, over here, x has to be greater than a 2. So you got to be thinking, in terms of your domain for our extraneous solutions. All right, I'm going to factor this out. X squared minus 2x plus 2x minus 4 equals 12. These cancel. I get x squared minus 4 equals 12. Option number 1, I can add the 4 over and get x squared equal to 16. Take the square root of both sides. Reminder that when you take the square root of both sides, x is equal to plus or minus 4. Option number 2, x squared, I'm going to subtract the 12 over and get minus 16 equals 0. Factor to x plus 4, x minus 4 equal to 0. X equals negative 4, x equals 4. All right, from here, either way, no matter which way you do it, I do have to check my solutions. So if I plug a negative 4 in, The very first one, I'm going to get the log of -2, and if I plug it in here, I'm going to get the log of -6. So therefore, -4 is a no-go. All right, but I can use the x equal to 4. All right, again, very similar problems, just doing it again. So very first thing I'm going to see on this one is I want to get the logs on the same side. I do not have a log here, so now my goal, my game plan is condense the logs, rewrite in exponential form rather than canceling. I can't cancel because there's no log with the 2. All right, so I've got log base 2 of x plus 4 plus log base 2 of x plus 1 is equal to 2. Condense log base 2 of x plus 4 times x plus 1 equals a regular 2. So now I'm going to change it into exponential form. 2 to the 2 power equals, and I'll FOIL this out just to save some time, x squared plus 5x plus 4. Set equal to 0. So 0 equals x squared plus 5x, because when I subtract this 4 over, it's going to cancel out with this 4. Take out a GCF. X times x plus 5x, not 5x, just 5. Okay, x equals 0, x equals -5. I'm going to check it with my domain. I can use a 0, okay, so that's good. I cannot use a -5, that'll give me a negative number in either of them. Okay, all right, this one. I see log, log, log everywhere. So condense first. Do not just cancel the logs right away. You always have to condense first. So now I've got log base 5 of x over 10 equal to log base 5 of x over 10. All right, I can now cancel the logs and I get x over 10 equal to x over 10. And most of you, when you see that you get the same answer on both sides, automatically go to the idea that, oh, it's, all real numbers. Well, reminder, domain. It can't be all real numbers because the x over 10 has to be greater than 0. So if x over 10 is greater than 0, okay, then that means x has to be greater than 0. All right, and there you go. That's 5, 5.